This video demonstrates how to build a confidence interval using descriptive statistics in Excel. This method is appropriate for a sample where the population standard deviation is not known. In this data set, we have a sample of n equals 30 families with a membership at a YMCA. We could calculate the average number of hours easily. The average is what is called a point estimate, a single number. However, we also know that when we pull a sample from a population, there's often a difference between the mean of the sample and the mean of the population, what we call sampling error. Therefore, we often build a confidence interval which allows for a margin of error on either side of the sample mean. Descriptive statistics is a function in Excel which makes it easy to build a confidence interval. Let's pull descriptive statistics and build one now. We go to Data, Data Analysis, and Descriptive Statistics. We select the data. I'm going to include the label in my data, and therefore I will click Labels in first row. I want my output range to be here on my spreadsheet. I'm going to select Summary Statistics and then indicate the confidence level I want to use in building my confidence interval, in this case 95%. The upper limit of our confidence interval is mean plus confidence level from the table, which is actually margin of error. The lower limit is mean minus confidence level, or in other words, margin of error. In this example, we say that we have a 95% confidence level that the true mean is contained within the confidence interval of 37.028 hours to 48.372 hours. It is appropriate to use descriptive statistics only when we have a sample from a population for which we do not know the standard deviation. Excel calculates the standard deviation in descriptive statistics using the formula for a sample standard deviation. Therefore, when it calculates the margin of error, or this confidence level row in the table, it is using the student's t-distribution to determine a critical value. When we carry out that calculation manually, we will get the same number with some differences due to rounding. In this video, we have calculated a 95% confidence interval estimate for the mean when population standard deviation is unknown using descriptive statistics. In this video, we'll build a simulation to demonstrate what is meant by a 95% confidence interval estimation of the mean. Let's build a simulation of 100 confidence intervals, assuming that we know a population's mean to be 100 and the standard deviation to be 10, with a sample size of 30, and see if 95% of our simulated confidence intervals contain the population mean. First, let's use Excel's random number generator to create 100 samples of size n equals 30. I'll go to Data, Data Analysis, and Random Number Generation. The number of variables is actually the number of columns, or the number of samples I want to create. I'm going to put 100. The number of random variables is the number of observations in each sample, or my sample size. I'll put 30. I'm going to pick normal for the population distribution, because remember that with a sampling distribution of a sufficiently large size, even if the underlying population is not normally distributed, the sampling distribution will be. My mean is going to be 100, and my standard deviation is 10. I'm going to have output in cell E2, where I've already set up my observations and my sample numbers, and I'll click OK. Now we're ready to calculate the mean, which I can do easily on the Home tab. I'll click the drop down by the sigma and say Average, and it will select everything in my column, and then I'm going to calculate my lower bound in my confidence interval. Excel has a neat formula that will help us out here called confidence.norm, which we use when we have a known standard deviation for the population. For the lower bound equals the sample average minus confidence.norm, and it asks for an alpha. The alpha is 1 minus my confidence level. I'm going to lock that cell. The standard deviation, which is the population standard deviation, again, I'm going to lock the cell. And the sample size, and again, I'm going to lock the cell. For my upper equals the mean plus confidence.norm, my alpha, standard deviation, and sample size. Now I can select these three values and drag them to the right, and my formulas are filled in. In 100 samples, we would expect 5 of them not to contain the true population mean. That's the meaning of 95% confidence level. 95 would, 5 would not. Let's take a quick look at the Countif formulas. The first Countif says that in our lower interval, if the lower number is greater than 100, it excludes 100 from the confidence interval. And if the upper number is less than 100, then it would exclude 100 from being in the confidence interval. We only have 7 of the confidence intervals which do not include 100, the true population mean. Note that I can now simply change the confidence level and the numbers will recalculate. If I change it to 99%, then we would expect about 1 in 100 would not include 100 in the interval. Or I could change it to 90%, and we would expect that 10 of the intervals would not include 100 in the interval, the true population mean. In this video, we have built a simulation of confidence intervals using Excel's random number generator and the confidence.norm formula when the population standard deviation is known. In this video, I'll demonstrate the use of the confidence.t formula to compute a confidence interval in Excel when the population standard deviation is unknown. Assume we have pulled a sample of size 30 from a population, and we have computed the sample average to be 100. We do not know the population standard deviation. We do, of course, have the sample standard deviation. If we want to develop a confidence interval estimate for the mean at a 95% confidence level, we will need to use the student's t-distributions because we don't know the population standard deviation. The confidence interval formula is sample mean plus or minus critical value times standard error, where that whole chunk to the right of the plus or minus is called margin of error. Excel's confidence.t function will compute margin of error for us. For the upper limit, we type equals sample mean plus confidence.t. Our alpha is 1 minus our confidence level, our standard deviation, and then the sample size is 30, close parenthesis, and that equals 103.734 to a lot of decimal places. For the lower limit, I'll repeat the same formula but with a minus sign, equals sample mean minus confidence.t, alpha, sample standard deviation, and sample size, close parenthesis. The confidence interval at a 95% confidence level for an estimate of the mean is 96.266 to 103.734. In this video, I have demonstrated how to use the confidence.t function to compute a confidence interval estimate of the mean when the population standard deviation is unknown.